In this video, we'll graph another rational function. 2x squared minus 2 over x squared minus 9. Okay, so what we want to do is find all the following, and that's going to help with our graph. The domain, all the different asymptotes, if there's any holes, intercepts, and then the graph. Okay, so break it down into smaller pieces. It'll be a little bit easier. So first, if we have to find the domain or the asymptotes, we always want to look at the factored form, right? So we can see this guy factors fairly easily. There's a GCF in the numerator, not in the denominator, and I factor out the 2, and then I'm looking at the difference of squares in the top and the bottom. So the numerator is 2 times x plus 1 times x minus 1. The denominator is x minus 3, x plus 3. Okay, so right away we can see that there's no like factors in the top and the bottom, which means there's no holes. The domain are all values for x as long as it's not equal to plus or minus 3, right? That would cause us to divide by 0, so they're excluded from the domain. If you want to do the work, you can set each of those to 0 and solve. You should get 3 and negative 3. I'll skip that step. And also, because there are no like factors, then those 2 points that are excluded from the domain are vertical asymptotes. So we got one at negative 3 and one at 3. Okay. How about horizontal asymptotes? So same function. To find the horizontal asymptotes, I'll look at this. Actually, the non-factored version is a little bit easier to deal with here. We can see that the degree of the numerator is the same as the degree of the denominator. So when x goes to infinity, the only thing that matters, these guys don't matter, is the ratio of the leading terms, because the degrees are the same. They're going at about the same rate. So we're just looking at the ratio of the leading coefficients, which is 2 over 1 or just 2. Okay. Because there's a horizontal asymptote and the degrees are the same, there's no slant asymptote. Slant only occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. The x-intercepts, we know we can find them by setting our numerator to 0. So you can see pretty easily what they would be. You have one at x equals 1, another one at x equals negative 1. The y-intercept you would get by plugging in 0 for x. So you have 2 times 0 squared minus 9 over 0 squared minus 9. I'm sorry, that should be 2 up top. And that should give you 2/9. So as points, if you want, it helps me graph them. 1, 0, negative 1, 0, and the y-intercept, of course, would be 0, 2/9. Right? So now we're going to try and bring all this information together and graph the function. So let's start with our asymptotes. Negative 3 and 3 vertical, y equals 2 horizontal. Right? So here is a horizontal asymptote. Here is a vertical, and here's another vertical. Okay, I'll use green to graph the function. I have a intercept here and an intercept here, and the other one was at 2/9, right? So I get a pretty good idea of what's happening in between these two asymptotes. I know that as x gets close to them, it's got to hug this line, so it's got to do that. All right, come up here, pass through these 2 points, and then back down here. Okay, I know we only found 3 points. You could find a couple more, like you could plug in, I don't know, 2.5. You should get an output down here. Negative 2.5, you should get an output down here, just to verify that this is what's happening in between the vertical asymptotes, okay? All right, so now I need to figure out just what's going on the other side of these vertical asymptotes. So I think with a couple test points, remember my original function is f of x equals 2x squared minus 2 over x squared minus 9. So I want to know what happens to the right of this vertical asymptote. That is for values like 4 and 5 and so on. So I want to test maybe f of 4. See what side of the line that's on. So plug in 4, you get 2 times 16 minus 2 over 16 minus 9, which gives you 32 minus 2, 30. 16 minus 9 is 7. Okay, so that's approximately 4 and a little bit more. So if I plug in 4, I get an output of about 4, somewhere around there. Okay, so that gives me just that 1 point. Just that 1 point right there gives me a pretty good idea of what's happening, right? We should choose several other points. But if I plug in 8, I should be somewhere around here. If I plug in 10, I should be there. The closer I get to x equals 3, the closer I should get to infinity, right? We talked about that concept of vertical asymptotes. So a couple more test points would be good. So you can test those on your own. But the one I got tells me where that function lives above that horizontal asymptote. I'm going to do one more back here, and you know what happens at -4, right? It should be the same output because when I square that -4, right, I'm going to get the same values here and here. Okay, so you have some sort of symmetry going on for this function. So a -4 input gives me a +4 and a little bit more output. And a couple more test points would be good. If you were to do those, you should get a curve that looks something like that. Good test points to pick, I think -10 would be a good one. Should put you right there. And if you want, you can get closer to this vertical asymptote of -3, and it should shoot you up there somewhere. Okay, so that's the sketch of the curve for this function.